All right. It's been a minute since I've skipped a few days. Oops. Because busy, I guess. So lost our streak again, but that's okay. Still in this robot thing though, which is fun. Okay, so a robot infinite XY plane starts at 0, 0 facing north. Robot receives an array of integers commands, which represents a sequence of moves that it needs to execute. There are only 3 possible types of instructions. -2, turn left, -1, turn right, and some positive number, move forward, k units. Okay. Some of the grid squares are obstacles. The ith obstacle is at a grid point, obstacles I equals x, y. Sure, yes. Fine, yes. If the robot runs into an obstacle, it will stay in its current location on the block adjacent to the obstacle and move on to the next command. Right, okay. Return the maximum square distance that the robot reaches at any point in its path. There can be obstacles at 0, 0. If this happens, the robot will ignore the obstacle until it has moved off the origin. Oh wow, that's annoying. However, it will be unable to return to 0, 0 because of the obstacle. That makes sense, yeah. North means y direction. Sure, so up, yeah, and east is positive x. That's fair enough. The furthest point the robot ever gets from the origin is that. So are we simulating? Is that all? Is that the main idea? We just have to really be able to really quickly figure out if we're about to hit an obstacle or not. That's like the main idea, right? Interesting. How many instructions can there be? 10 to the 4. And then there can be 10 to the 4 obstacles. This is, the answer's guaranteed to be, okay, that's nice of you, yeah. Okay. I mean, I can't figure out, I don't know, like, so I'm assuming this is just a question of like making sure you have a good data structure to be able to figure out if you're about to hit a obstacle or not. So like, so this is 874 POTD. Oh, I forgot to say the date. 6th of April 2026. Okay. I mean, okay, so yeah, let's go through an example. So let's go on with obstacles. So commands are 4. So this is example. 4, -1, 4, -2 and 4. This is commands, and then obstacles is 2, 2, 4. Okay, so you're starting at the origin at 0, 0, right? Okay. So the starting point is here, and the obstacle is at 2, 4. So here. So if green is your position, you go 4 here, at which point your current, I guess, displacement is 4, 0. That's nice. You go -1, which means you turn right, so you're now facing like this way. You go 4 across, but you hit this obstacle, so you actually only go 2 across, I think. So you're 4, 2. You go -2, which means you turn left, so you're facing this way now, and you go up by 4. 1, 2, 3, 4. It's like over here. So you increased your. Hold up, did I go the right? Oh my goodness. It's 0, 4, you silly goose. And then 2, 4. Then you go up by 4, so it's 2, 8. So your biggest magnitude squared would simply be the square of these two numbers. 2 squared, 8 squared, 64 plus 4 is 68. Does that work? Oh. 0, 4. Oh. Right. Sorry, you don't actually go to the obstacle. My apologies. You go 1 before, and then you go up by 4. So it's 1, 8. I misunderstood. So the obstacle is here. I guess it's more like you gotta think of like a grid. So like if the obstacle is here, and he started here, went to here, but then couldn't go here because of the obstacle. I guess that's what happened. He started at 0, 0. 1, 2. Oh, I messed up. 1, 2, 3, 4. There you go. 1 and then up by another 4. So you get 1, 8. So it'll be 1. So 64 plus 1 gives you 65. Okay. So the question becomes okay. When moving forward, let's say by 1 unit, suppose my current position is x, y. If I'm moving, let's say up, like, so, i.e. the y coordinate, increases by 1. So it just becomes a question of, does x, y plus 1 exist in obstacles? If it does, then this, you can't move, basically. You can't move. Does x, y plus 1 exist in obstacles? If it doesn't, then you're happily able to move there. Now, my concern is if I do simulate one step at a time, if a command, oh wait, a command is up to 9. Maybe it's fine then, because the number of steps the robot can take is 9 times 10 to the 4, as in terms of maximum, because you can do 9 steps in one command, and you have 10 to the 4 commands, which is less than 10 to the 5. So yeah, that's still fine. Okay, so I think simulating each step is fair game. I thought that would be too inefficient, but that's fine. What was this about? Oh, this is just the side. Okay, this is just like your space, your XY plane. That's fine. Okay, so then if I just put each obstacle in a set, that should make the lookup. I mean, obviously, I can't put lists in sets, but I can make them into tuples and then put them in sets. That should be fine. It's not like I'm gonna have to change them or anything. If they're immutable, that's fine. So yeah, put each obstacle in a set. The only thing is, like, if the 0, 0 is in the obstacle thing, don't put it in immediately. Oh, maybe it's, no, actually, no, you can actually ignore that, sorry, that's fine. Because it's not like, yeah, the logic will still hold. Like, if I put 0, 0, it won't, when I do a move, it won't look for 0, 0, it will look for like 0, 1, or 1, 0, or negative 1, 0, or 0, negative 1. Like, it's not gonna look for 0, 0, so it's not like the robot's gonna get stuck on the 0, 0 because if there's a 0, 0 obstacle, so that's fine. So yeah, put all the obstacles in a set, and then just, yeah, simulate. And then the only extra thing is I have to make sure I keep track of the best, or like the furthest distance, square distance. So what do I have to do? Well, I mean, no, I can, no, again, if the simulation is fair game, then I can just check. I can keep track of the current displacement vector. Alright, which would be like some kind of, I'll call it dv is equal to 2 things that I update. And then I can just do a quick, like x squared plus y squared, like the squared Euclidean distance is going to be the x squared plus y squared. And if it's bigger than the current answer, then yeah, that's fine. Okay. So answer is equal to 0. Displacement vector is equal to 0, 0. So yeah, I won't call this answer max squared Euclidean distance. Is that, and then yeah, I mean, maybe I have a direction constant, or not constant, like a direction. North. Just have constants. I'll have globals at the top. North equals 0. Do I want north or up? What's better? Right. I mean, they use north and stuff, but I feel like in my brain, it's easier for me to think about. Although, I wonder if it's, considering that -1 basically means turn left. Sorry, -2 means turn left. So we go from up to left. If I do -2, I wouldn't really do anything with it. Okay, I think it's fine. Def, maybe I'll have like turn left. And then just like if current direction equals up, then turn left. If current direction equals left, then return what, down? If current direction equals down, then return right. If current direction equals right, then return up. Is this a dumb way of doing it? Yes. In fact, this could be an array, couldn't it? Where the index 0 corresponds to, like, would be like left, down, up. Wait. When you turn left, because I did this in a weird order. If I say left, down, and right, I think, yeah, I could literally, I think this would be right. Nope, no it's not. Accessing 1, this should say right and this should say up, that's what it is. Like, I could make arrays to do this instead, but I think just for the sake of readability, and so that I don't have to think too hard, I'll just do it like this. Turn right. So right, if it's right, go down. If it's down, go left. And if it's left, go up. Okay. So I have nice easy methods that will let me do stuff. And then we'll say turn left is equal to -2 and turn right is equal to -1. Alright, for O in obstacles, we'll say all obstacles is equal to set. For each of these, all obstacles dot add the tuple of O. Tup, very good, well done. Yeah, and then what did I say? Simulate, right? So for commands hang on, let me make these as well. Self disvec, given the distance vector, this vec at index 1, the y coordinate, maybe we'll do that as well, x equals 0, y equals 1. The y coordinate should increase by 1. Same vibes. At y should decrement, and very similar. Left, or maybe right and left. So this is x, this is x. Fantastic. Okay. So for command in commands, if command is equal to turn left, then current direction is equal to self dot turn left current direction. Elif command is equal to turn right, the current direction turn, oh my god. Else for step in range com, because we know it's this case now. How do I do this? Because I have to first check if that thing exists. So how do I? It's the cleanest way of doing this. Because I don't want to move yet. I want to first check. If about to hit obstacle. Given the all obstacles set, given the current direction. Okay, I guess I will do this. Yes, self as well. I need the displacement vector, don't I? Okay, so I'll just quickly make a copy. So copy if, and then left. I feel like I'm starting to do a bit too much now, but I was just trying to keep things nice and modular, you know? I don't know why I did this in this order, but anyway. Okay. So we'll say self.move, copy this, no, yeah, copy this vector and the current direction. If tuple of the copy this vector is in the set all obstacles, then return true. Else we can return false. Okay. So if you're about to collide, given all the obstacles, the current direction, and the distance vector, then I guess it'll break out. Else, self.move given the actual disk vector and the current direction, and calculate squared Euc distance given the current, the disk vector, turn disk vector x to the power of 2 plus disk vector, disk vector y to the power of 2, right? X squared plus y squared. Yeah, just do a quick update. If calc self calc squared Euc dist. Actually, I don't have to do a variable. Equals the maximum between this, given the dist vect, and that's it. And then when you break out, maybe do it one more time just in case. Oh, no, don't break out. You didn't move, so you would have already checked. Sorry, I just said that wrong. When you break out, there's no need to do this again, because if you broke out, that means you didn't move, so that's fine. Okay, and then return. I didn't say what it should max with. Return this guy. Is it correct? Well, I made this way too complicated. I thought I was being clever, but I ended up being stupid. Whoops. North. Do I trust it? I think I do. I don't know. Alright, let me try bumping back into let me try an example where I bump back into the origin. So like, you start over here, there's an obstacle at origin. Let's say you move 1 to the right and then move 5 left. Right? So the actual command should be turn right, whatever that is, move 1, turn left, and then turn left again. I guess you could turn right again as well, actually. I'm trying to do a full 180, and then 5. And the answer should equal 1, because you shouldn't be able to go back, Alright, so how do I do this? What do I have to give? Commands? Just commands? Commands and obstacles. Oh, yeah. So turning right is -1, then I move 1, then -2, -2, and then 5, and my only obstacle, that's 0, 0. Oops. Sorry, what? -1 It's not a valid value of type integer. Okay, it's not meant to be 2D. My apologies. Okay, so it seems to be able to handle the logic of like don't go back to the obstacle, even the origin obstacle. I don't really want to test this. I think it's relatively correct. Okay, it is quite slow. I imagine that's because there's cleverer ways of doing it without doing a simulation on each step. But, you know, based on constraints, found that it would work. I wonder how you would be cleverer. My only thinking is like, instead of looking for a very specific obstacle, let's say, you know, you're over here and there's an obstacle over here and you've been told to move up in this direction, right? My sort of thinking is you somehow have to search the space for an obstacle sort of in this region. Like, let's say you've been asked to move up this far. Then you're looking for, like, I guess the first or the earliest obstacle in this sort of space. Maybe there's two obstacles, but you care about finding this one first, right? What would you do in that case? I would imagine it's something to do with, like, because if you do this like this, if you're able to find this obstacle straight away, you don't have to like do individual steps until you eventually hit it, right? You can just go for it straight away. You can find it straight away and immediately move up to where you can go. Something about like maybe like query tree, like segment trees or something, like where you're trying to query for a range. It's tricky though because it's two-dimensional. There's two directions you can have to search in. Like, you have to keep the x value in this case fixed, you know, -2 for example, but then the y value, if it starts at 1, let's just give some numbers. Let's say you're moving up to potentially 5, because let's say the command here was, you know, up by 4. So, yeah, maybe you're going up to 5, or maybe I'll say 6 just to make it a bit bigger. So you're moving up by 5. You started at 1, you're going up to 5, and like there's an obstacle at 6 and there's an obstacle at 4. Right, so you should only be able to move up to 3, really. Right, you should only be able to get up to here, even though the command wants you to get sort of up to here, you know. So if that's the case, how do you quickly find obstacles that are, first of all, at this x value, at this x value, -2, but then also are within this range of -1 up to -6. I would think it's something like, maybe you have 2 copies of obstacles, and then like the reason you have 2 copies is because you have one that's sorted by, or not sorted, oh yeah, sorted by x coordinate, and then one that's sorted by y coordinate. So the reason why you have both of these is, whoa, I didn't do that. The reason why I think this might be helpful is because in this case, because we're keeping the x coordinate fixed, you would look at this copy. You could probably use binary search to find the sort of region of obstacles that have x equals to -2. Maybe x coordinate then y coordinate, versus this one would be sorted by y coordinate first, then by x coordinate, in the sense that the sorting prioritizes the y coordinate, then the x coordinate, whereas for the first copy, it prioritizes the x coordinate, and then for ties, if 2 obstacles have the same x coordinate, then you sort the y coordinate. That way, in this case, if you were to binary search all of the obstacles, you would slim it down to the ones that are in this column, right? Anywhere along this column. And then from there, because we further sorted it by y coordinate, within this region, it's sorted by y coordinates. So after you do that, you can then binary search again to find obstacle in like this region. So like what's the first obstacle that is past the y=1 coordinate, and then what's the last coordinate that is before the y=6 coordinate. I think you could do it like that. Binary search again to find the obstacle in the y=1 to y=6 obstacles, and then pick the earliest one, and then from there you using log n time, because you did like, well, you did n log n stuff here, but this is like pre-processing, so it barely counts. The binary search stuff, you basically do like, I want to say, do you have to do 2 binary searches for this to work? Because you have to figure out like the first instance where binary search, I think you have to do 2 instances of binary search for this first half, and then 2 instances for the second half. I could be wrong, because in my mind it's like you have to figure out what is the earliest obstacle in the array that has a -2, and then what's the latest one that has. So you might have to do 2 instances of binary search to do that comfortably, and then binary search again within this range, binary search again to figure out where this position is, and figure out where this position is, and then you can, that should give you the region of space. Anyway, should be fine. Oops, meant to do that one. Hash set, fair enough. I think this guy looks like he did a similar. Wait, okay, I'm not gonna bother actually too much because I've got to do some other stuff, but let me just look at the topics. Does it say binary search at all? No. Okay, well, maybe, I guess because sorting does ruin the time complexity, so maybe it's not worth. But I did, maybe I'll read this in my own time. I feel like I did, I mean, it's simulation, but yeah, maybe this is just too complicated. Maybe I could have simplified it down. Anyway, I'll read the solutions in my own time.